Hello, welcome to Just Maths. Today we'll be looking at deriving the sine, cosine, and tangent of angles 30, 60, 45, and 90. If you are given this plane shape, an equilateral triangle with sides 2 and angles 60, can you derive sine, cosine, and tangent of 30 and 60? What if you're given a square shape with sides 1 each? Remember, a square has angle 90s. All of the angles in there has 90. Now, can you derive sine, cosine, tangent 45 and 90 from this? Today, I will be showing you how to get the exact value of the trigonometry of sine, cosine, and tangent 30, 60, 45, and 90. Now stay tuned, I'm going to give you the solution to this. Now let's start by deriving angle 30 and 60. First, what you need, remember I told you we will need an equilateral triangle. Okay, now the equilateral triangle has sides 2, 2, 2, then angles 60, 60, 60. Now, if we have to divide this into half, okay, we have a right angle triangle. Now, this right angle triangle, we use one part of it, okay, where we now have 30, 30 at the top, then 1, 1 at the side, okay, because the division has given us the 60 to be 30 each. Then the size, which was 2, gave us 1 each. So we are making use of one of the parts. Fine. Now we have to look for the height of this triangle. Okay. And to look for the height, we have to make use of the Pythagoras theorem. Now the Pythagoras theory, the height will be y. Okay. So y square equals to 2 square minus 1 square. 2 square gives us 4. 1 square is 1. So 4 take away 1 gives us 3. 3 is not a perfect square, so we leave it as square root 3. Okay. So the height is square root 3. The hypotenuse is 2. The adjacent is 1. Now take note, the opposite and the adjacent solely depends on where the angle is facing. Okay, now we have angles 30 and 60. If we are to look for angles 60, the opposite of angle 60 is square root 3, while the adjacent of angle 60 is 1. If we are to consider angle 30, the opposite of angle 30 is 1, while the adjacent of angle 30 will be square root 3. It's only the hypotenuse that remains the same. It doesn't change. So the hypotenuse remains 2. So with this, we can derive the sine, cosine, and tangent of angles 30 and 60. Okay, let's take one for an example. Let's look for sine 30. Okay, sine 30 happen to be opposite over hypotenuse. Now, the opposite side of 30 is 1 and the hypotenuse is 2. So sine 30 will be 1 over 2. Sine 60 will be root 3 over 2, opposite over hypotenuse. Now I will leave you to work the cosine and tangent of 30 and 60. You can pause the video and write out the cosine and tangent of 30 and 60. Now, if we have to work out that of a square, we can derive angles 45 and 90 from this. Okay, now the square, remember how we made the square? The sides are 1, then dividing the square diagonally, we have 45 and 90. Now, if you notice, the only part missing here is the hypotenuse. And now we can use the Pythagoras rule to find the hypotenuse. Okay, and having done that, we arrive at the square root of 2. Now, with this, we can work out the sine, cosine, and tangent of 45 and 90. Having derived this, we can find the sine 45. Okay, that will give us opposite over hypotenuse, which is 1 over root 2. Okay, you can as well find that of cosine and tangent of 45, then sine, cosine, and tangent of 90. Now, this is how to derive the exact value of the trigonometry 30, 60, 49, and 90.